So this tech talk is about the AI Hackathon we've had for going on for over the last couple months. The three teams submitted um, their submissions in the past week, and we'd like to go through and do a little demo for each submission here for the tech talk. So without further ado, Paul, do you want to take it off? Take it on, rather. Oh, Paul, you're on mute, I think.
Sorry about that. Sitting here talking for a few. Yes, thank you about that. Yes, let me get ready to share my screen over here. But again, AI's come a long way, and it is one of the very hot topics we have right now. And one of the things I thought about, and as far as like a good business type venture, is try to utilize that AI in offering customers different ways to share their data. First of all, the government has an incredible repository of data that we put out there. Right here, there is a site, data.gov, which hosts many open databases that belong to basically, our taxpayers paid for this research, paid for these databases to be generated, so they're hosted here. So I was thinking maybe reaching out to organizations like this who have these enormous sets of data and giving them a different way to present that data to the public. Uh, you know, it's nice, some of these may be in the forms of straight up SQL databases. Some of these may be in the form of just a simple CSV, but it's how can we bring them a better way to present that data to the public? To me, the growth of the AI and LLMs has kind of given that opportunity. So just kind of as a proof of concept, what I decided to do is pick one of the more popular databases here, which is just the FDIC Feld Bank, which is almost essentially just a CSV file. And it keeps track of all the banks that have failed in the United States that were insured by the FDIC, where they're located, when they failed, which bank acquired them, the date they closed, information like that. So I thought, hey, why not try to incorporate that into an LLM on FDIC where somebody can come in and rather than having to download the CSV, generate queries, know how to convert that into some sort of queryable language, put that in an LLM model, give them the ability to come in and say, hey, FDIC, can you tell me if any banks closed in Texas? Sure, let me give you a list of the banks that closed in Texas. Incorporating again the use of an LLM to understand that. So, what I did basically was start off with this basic information, which was download their actual data that they provide here. And that came in the form of, just a straight up CSV. So something like a bank list with all the names of all the banks, where they're located from, who acquired the bank, the date it closed, stuff like that. Took that, did run some simple, little simple Python script that can read a CSV file. Take that, and what you want to do here is for an LLM is what you're going to want to do if you're going to train an LLM is you want to prompts, something that gives that large language model a context. Because the biggest thing that I should have started with this. One of the biggest things about the data provided on data.gov is it is simply data. There is no context to it. When you're looking at a database or when you're looking at just a CSV file, it does not provide context. So a large language model itself it can read a database, it could read, a CSV file, but without any context, that large language model doesn't know what it's reading and it doesn't know what it's looking at. So to do some custom training for a potential customer, it's like, let us take your data, let us generate prompts, let us train a large language model to understand the context of your data, not just printing out the data itself, but it has to have context. So again, simple prompt generator here, just in Python that would read that CSV file, and then I'm going to create something like prompts that's going to give the large language model some context. So here, we're telling the large language model structure, hey, you're an FDIC research assistant here to answer questions about FDIC bank closures. So again, you're kind of giving it a personality. Here, again, depending on the demands of a customer, we could say, what type of personality would you like your model to have? What type of, answers would you like to give it to respond with? The input in, again, I generated prompts for every state. I did generate it both by state initials and by state name. So if somebody would come in and say, which bank's closed in PA, which bank's closed in Pennsylvania. And then here, my output is parsing that CSV file. So I basically parsed that CSV file, the banks that closed in Pennsylvania are, and it went through every entry in that CSV file, separating it by state, both the initials, the name. Again, this prompt database that I generated was a few thousands of lines. Not only did I do every state, I went through, because of the way the CSV was generated, I generated it by city, by state, by year, which banks closed in 2000. Again, if we were doing a lot more training, we could train it to do it by year and state. Again, you're anticipating some of the questions somebody may have, and you're trying to give that large language model some context so that it can do that. So that's what I did, and that's what I used to do my prompt training model. So again, this generates all that information. And then here's where I'll say it was a fun experiment, not as successful as I had hoped it would be, though. I think one of the issues I ran into was trying to decide what to use as a base for a large language model. I decided to try to do this against MetaLlama 3, which is put out by Facebook. And that's their large language model. It was able to get there and use, rather than ChatGPT, which is the OpenAI model, but the OpenAI model has a little more cost to train. It's built-in cost. So I decided to go with the Llama 3 model. Again, for those who don't know, this is Google Colab. It's a thing Google offers that lets you play with some large language model stuff. What it does is it essentially lets you get access to a high-end GPU to do the fine tuning and training. And you just give it all the instructions you need. Again, here's some of the basic stuff, just loading up the packages that are going to be used. I pulled MetaLlama 3 from Hugging Face, so I did have to connect to Hugging Face. Again, I'll initialize that by loading the MetaLlama 3 database or large language model into the system first. And that's all this is doing here. I did run a brief test where I questioned MetaLlama beforehand to see what kind of results I would get. And I basically asked it, which FDIC banks closed in Texas. As you can see, it did pull up a certain list. Again, these are things because MetaLlama 3 was trained off of web data that it did find down there, and it was able to answer in a certain way. Then after I asked it the test question, I started to train it on the data set. Here's where you'll see I uploaded that JSON file that I shared earlier with all the prompts. And then I set it to train off of that JSON file. Now, what I did was used what they call a low rank adoption method, which kind of adapter method, which goes through and trains them and gives them a little ranking outside of it that'll then be combined with the large language model to try to say, hey, along with the large language model, I want you to look at this particular set of data that I trained on. So that's what this is doing here. It's training it on that set of prompts I gave it. I will say when I did train it, some of the training methods are batch sizes, to read at a time, how much weight you want to give to that, how many epochs, which is how many times you want it to go through and read that data set. The more times you can read that data set, I think you get a better chance of getting better context and understanding within the large language model. That said, I think that's where I may have messed up a little bit, because we want the data to to almost stand out and almost say, no, this is literally the response I want you to give when this question is asked. Actually, I think fewer epochs, or maybe even just one epoch, would actually be better than doing the multiple epochs like I did. I did a 5 epoch, so it ran through it 5 times, which took about 2 hours to train an extended data set. But the problem is that trains the model in a lot more context, but I think moves it away from just the one-time read, which says, hey, just look at this and let's not try to generate too much context off of it. Instead, let's focus on what's actually being said. So I did do that. After I trained here, you'll combine your newly trained model. You combine that with your pre-existing model so that it is now a singular model that's being used with an add-on to try to answer the questions. So here you can see I kind of asked the same question again. You can see the answers were a lot, the context was understood a lot more. The list was kind of generated with a little bit more information, but it was not pulling specifically from the trained data. So here's where I feel like I would need to find a better way to try to get it to pull directly from that trained data so that we're providing answers that are specifically trained from the data we receive from the customers. When you are querying, these large language models do have some parameters and tokens. I did change a few tokens and parameters. There's one called temperature, which the lower the temperature, the more it'll try to use what's in the adapter versus what's in the large language model. So doing that, again, asking the questions, getting, again, a more refined answer, as we train this. And that's basically my attempt at this. A lot of lessons learned. The lessons learned is, epochs and training do matter. Prompts do matter, how we do the prompts, ways to focus that prompts, and also type of the base model, I think, will also be very important, whether or not you use something like a ChatGPT as a base model or a Metalama 3. There's several base models out there, whether or not it'd be better to use a base model that is trained on a smaller set versus a larger set, might give us better focused results. So these are just some of the lessons learned. Again, the base model itself, though, is still very important because you still want the service we would be offering the customer to still try to understand as much of a robust language as possible for it to get general concept. So when questions are asked or when data is asked for, those concepts are understood and it knows what you're looking for. But that was the general idea of, kind of going through, looking at something like data.gov, identifying customers who have large sets of data that would do well in an environment that would provide the public an easy way to get answers on that data sets, rather than having the only people right now who really grab those data sets or use it are the people who are going to know how to grab a CSV and maybe manipulate it into pivot tables and generate the kind of answers to the questions they have. Or if it's even more technical, something like grabbing a SQL database online or, any other database format, you would have to have somebody who understands SQL, how to do queries, how to do this, how to get answers from that data, where this would take that same data and provide a more robust way to get answers from the data that's existing out there. But that's what I have. Anybody got any questions on that?
Yeah, just for the interest of time, just make sure the other teams get in here. So we'll probably have 2 or 3 questions. So we'll open up to the floor. Hey, I'll just go ahead and say thanks, Paul, for presenting. Very interesting. You've done a lot of work for this AI hackathon, and it's very much appreciated.
I appreciate you guys putting this on. It's a field I've really been wanting to dive into, and this opportunity was really great. Thank you.